To show how resistance acts in series, I'm going to be using 3 small lamps and measure the current that's going through the lamps as I add more in series. And obviously a lamp is a conductor, therefore it has a measurable resistance. It's not a very large resistance, but it's a resistance nonetheless. So I've got one lamp attached and the ammeter is showing 53 amperes. I'm going to add another lamp in series. And you'll see the current has dropped. So if the current has dropped, that means the resistance must have increased. To add another one in series, you will see that the current's dropped even further. So in other words, by adding lamps all the same, but resistors in series, the resistance must increase, hence the current decreases. Now, to do the same, but in parallel, you'll see back to the one lamp situation, back to 50 amperes or thereabouts as it fluctuates. I'm now going to add, there we go, I'm now going to add a lamp in parallel. And you'll see this time that the current has almost doubled. So it's gone from 50 amperes to nearly 100 amperes. And to do one more, so adding another lamp in parallel, the current increases by another approximately 50 amperes. So quite clearly, or I hope it's clear, that when I add lamps again, but resistors or components with resistance, when I add them in parallel, the current increases the more I add in parallel, which therefore should be clear to you that when you add resistors in parallel, the total resistance goes down. In series, adding resistors increases the total resistance, hence the current drops, but in parallel, adding resistors decreases the total resistance, hence the current goes up.